Close your eyes and imagine. Wait. Don't close your eyes if you're driving. But imagine with me a small town in Alberta. A couple thousand people maybe. And that small town wants to reduce their greenhouse gas footprint. They want to be more sustainable. So they put up some wind turbines and some solar panels. But what happens when the wind isn't blowing or the sun isn't shining? They still want their lights to turn on. So maybe what they need is something, somehow, to store that power when it's windy or sunny and to deliver the power when they need it. Well, what if they could make a battery, a big battery, out of stuff we already have in the province, out of things like sodium and sulfur, out of things that are cheap and abundant? Enlighten Innovations was developing a cost-effective, low-sulphur marine fuel to address new international shipping regulations. And they stumbled across something big and ugly, something game-changing, a ceramic membrane that uses regular old, plentiful sodium as the foundation for a long-lasting, megawatt-scale battery. So we sat down with Neil Camarta, Enlighten's president and CEO, to discuss using new technology to create new batteries for new markets and industries and towns, here on Carbon Copy. I'll start with the most basic of basic questions. Maybe just introduce yourself, the organization you're representing, and very briefly, if you'd like, the role in your role in the organization.
Right. So, Mark, I'm a chemical engineer, an Alberta chemical engineer. I spent about 30 years in the oil and gas industry, with primarily with Shell. I built large oil and gas projects around the world. I loved it. I got to spend billions of dollars. Nothing more fun than that. I really enjoyed that. And then I retired, and I decided to actually put my money where my mouth was. Because when I was in the oil and gas business, I always said, look, it's just a matter of technology. Every time you can improve a technology, you can make things cheaper and cleaner. And so I decided to make that happen when I retired, and we started a technology development company, myself and my business partner Guy Turcotte, also a good Alberta chemical engineer. So together we started Enlighten, and I love it. I mean, it's not easy. I mean, technology development isn't for sissies, but we've had a great 10-year journey, and we got some great tigers by the tail right now. A couple of interesting technologies that we are about to commercialize.
So help me understand how the technology works. What's going on inside of the reactor?
Right. So there's 3 steps. There's the first step is it's like your kitchen blender. It's like a mixer. What we do is we mix heavy oil with sodium, and which makes it completely different than any other oil upgrading process. Typically, you use catalyst and hydrogen, a lot of energy, a lot of heat, a lot of greenhouse gas emissions and so on. Sodium is a tiny little atomic scale material. It goes right inside the big molecules, just like it had eyes, like a cruise missile. Pulls out the sulfur, pulls out the metals, and it's exothermic. It actually creates heat, so you don't have to put energy in. It actually generates heat. So that's how the reactor works. The next step is a centrifuge. When the sodium reacts with the sulfur, it makes a salt, like a yellow table salt. We remove that in the centrifuge, so that's the second step, very simple step. And in the third step, we have to get the sodium back so we can use it again in the reactor. And we have an electrolysis system there, like a battery, like a car battery. Instead of having lead plates, we use ceramic plates. So 3 steps: reactor for mixing the sodium with the oil, a centrifuge to separate the sodium sulfide from the oil. Then the oil now is all cleaned up, it goes off to the market. And the third step for recovering the sodium.
And I'm curious, what happens to the sulfur after it attaches to the sodium and then you pull it apart?
Right. So in this battery, that's kind of the unique part of this whole process. in the battery, we put electricity in. That's the only energy input in this process. Really, is the electricity we put in this battery to separate the sodium from the sodium sulfide. So we do that, the sulfur builds up, and we remove the sulfur just by we have a part of the process where we cool it off, and the sulfur drops out as elemental sulfur. So it comes out as a byproduct, Mark, from the process.
I understand you've essentially stumbled upon a big opportunity with the technology. Can you tell me about that?
Right. So we were working very hard on scaling up. That's what chemical engineers do. We scale things up. We take something that kind of works and we make it work better, and then we make it bigger. And so we're scalar upperers, and that's what we were doing. And that's all going great. About 2 years ago, remember, COVID started, oil prices tanked, and things went a bit pear-shaped. So we said, well, okay, that just slow down a bit here. But that's take a second look at this process, because this electrolysis system, this battery, it really wants to be a battery. I mean, if as soon as you stop putting electricity in, the sodium wants to go back through. It wants to behave like a battery. And well, maybe there's something to that, because 10 years ago batteries weren't a thing. Now they are a thing. And 2 years ago we knew that was coming, and we took a look at that as a specific application, and started to develop a standalone battery application. So, virtually out the side of this oil process, Mark has rolled this little Easter egg that's hatched into this battery, and it's got its own legs, and it's got its own market, and it's got its own investor interest. So it's a separate, standalone application of the same electrolysis system, just that it goes both ways. We could charge it and discharge.
So if I understand correctly, you've been essentially developing a more or less heavy oil processing technology, and you serendipitously discovered a big opportunity to use the reactor, in essence, for a battery. Is that correct?
Right. We were focusing hard on developing a clean process for upgrading oil. And we got there. That's and $100 a barrel oil, that's got its own market, its own investor interest now. Oil prices are back. We're building a demonstration project. That's all good. But as a separate thing altogether, we now have this battery, and it's not a simple it's not a lithium ion battery. It's a big, I call it a big ugly battery, Mark. It's a big chemical engineer's battery, and what it's good for is grid scale storage. So it's not the kind of battery you put in a laptop or a car or an iPhone, but it's the kind of battery you'd use to back up windmill farms, to back up solar farms for long duration. For example, last summer in Alberta, Mark, we had, I think, over 20 days, no wind at all. And so if you're relying on windmills and you have no wind for 20 days, you need a big ugly battery. And that's exactly what our battery is. It could store for days, weeks, months, just by adding more tanks.
So, I mean, you talked about this a little bit in terms of after putting electricity in, essentially, you noticed it wanted to go backward. Was there a big aha moment in this discovery? Was there a story about how that came about?
The aha moment was when we knew that it wanted to go in reverse. We just didn't know how well it could perform that way, and until we actually started to let it do its thing. It naturally wants to discharge, and we never tried it before, so we weren't sure how it would perform, if it would be competitive. So the aha moment was, hey, it works. This thing not only discharges, but it discharges at a very high efficiency. And then we started looking harder at our battery and how it compared with other batteries. And a couple of key things. It's got very high energy density, so you could store a lot of energy in a very small volume. And number two, the battery is cheap. It's made, we use sodium and sulfur in the top 10 of elements on Earth, so ubiquitous materials. The battery, the plates themselves are made from sand, so I don't have to go to Africa for cobalt. I don't have to go some other country for lithium. Everything we can make our battery right from everything that's right there in Alberta. So make it from local materials. and it's very safe. There's no risk of a lithium fire, that sort of thing. It's intrinsically safe. So it's a classic engineer's battery, and it's cheap, and cheap matters in the battery business, Mark. And we've been working on it for 10 years, and it's just an extension of all the work we've already done. It's ready to go.
You called it a big, ugly battery. I love that, by the way. And now there's a battery in my phone, maybe a small, sophisticated battery. There's a battery in my laptop. There's a battery in the headset that I'm wearing right now. So why is this a big deal? What does your battery do that other batteries can't do?
Right. So batteries are, I'm a chemical engineer, so batteries are actually a pretty simple thing. They're just chemicals, Mark. They're just chemicals that, go one way and then go the other, and that's what we have. That's what you have in your headset and iPhone. So lithium ion are great. They're cheap. They're manufactured at huge scale, gigafactories, that sort of thing. But they're only good for about 4 hours of storage. That's it. 4 hours and you're done. Maybe up to 8 hours, but not much more than that. And if you're going to be backing up windmills, if you're going to be backing up a windmill farm in Alberta last summer, or backing up a windmill farm in the North Sea last year as well, where they had wind droughts, you need to have more than 4 hours. You need 12 hours, 24 hours. You might need a week or two of storage. And in your case, if you wanted, in lithium ion case, Mark, if you wanted to have 12 hours of storage, you'd have to have 3 times as many batteries. In our case, you just add tanks. We just add, if you wanted. So I'll give you a good example. So a small town in Alberta, a couple of thousand people, that'd be about 1 megawatt of power is what they need. So the windmill farm's there behind the town, and this big ugly battery is sitting out in front of town. There's 2 sea containers, by the way, not so ugly. So that's it. That's all you need. And so 1 sea container would be 1 megawatt of battery, and another sea container would be 12 hours of storage. And let's say the people in town say, well, we'd like to make it 24 hours, so just add another tank. So in our case, we just add tanks. Tanks are cheap with this sodium sulfide solution in it. So it's really great for big up applications where you got megawatt scale. It's good where you want long duration, and it's dirt cheap, and all the materials are just pretty easy to come by, Mark. That's the difference.
So if you don't put this in a vehicle, you don't put it in a phone, you don't put it in a laptop, what are the competitors for this battery technology?
So lithium ion is a competitor, and they're good for 4 to 6 hours of storage. There's other, we call our battery a flow battery because we have these tanks full of chemicals. There's other flow batteries out there. They have puts and takes. They are typically more expensive. They have much lower energy density. So one of our competitors, we can put our battery, 100 megawatt battery, in 3 acres. It would take 30 acres for them. So we think we have a real leg over other flow batteries. And you get to 12 hours plus, we have a real advantage over lithium ion, just on cost. We're much cheaper. You get up to 100 hours, that's when other types of energy storage can come into play, like hydrogen, Mark. So I think we own the space between 12 and 100 hours. When I look at our technology and I look across at other competitors, not just batteries, but other technologies, I can't see anything in that 12 to 100 hour space that beats us on cost, Mark.
Yeah, you've talked about cost a fair bit, which is really exciting. Can you compete against some of the other large storage technologies like pumped hydro?
Right. So pumped hydro, again, that's a good technology. It depends where you are. So you have to be able to be in the right kind of terrain. You have to have the right, vertical distance for pump hydro to work. And it's good for longer duration as well. So I'd say kind of over that 100 hour time frame, pump hydro comes into its own, Mark. But in that again, we're kind of looking at that 12 to 100. So hydrogen, pumped hydro, pumped air, those storage systems are better for 100 hours plus. But they're good, proven technologies. And again, you have to have the right terrain for it. but we can put our big ugly battery anywhere. We're agnostic as to what the terrain's like. You can just plunk them down anywhere.
So cost is certainly an important metric, if not, one of the most important metrics. But as you know, one of the other key metrics for any energy storage technology is what we call round trip efficiency. If you put 100 units of energy to store for a day or a week or a month or 100 hours, how much do you get back out and how much is lost?
Right. So if you put 100 units of energy into our battery, Mark, you get about 70 units back out. So our round trip efficiency is about 70%. Now, that's not limited by the chemistry. It's just limited by the engineering. So we continue to work on that. Of course, we want that to be higher. The higher, the better. For example, lithium ion is over 90%. I believe the vanadium batteries are in the high 70s. And I think that we're at the bottom of our development S curve. We should be able to push into the high 70s as well, Mark. But it's not just round trip efficiency; it's cost as well. So you can afford a lower round trip efficiency if you have a very, very low cost application. We think we certainly have the cost, and we think we can improve our round trip efficiency as well, Mark. Just more development, better engineering.
Where do you put then a big ugly battery? Are there any limitations or restrictions in terms of where you can locate it? Any safety concerns?
Well, it's big, so it's not going to be something you can hide behind your house or whatever. So it's not really suitable for residential, unless you're in a bigger neighborhood or something. Like probably that small town is probably about as small as you want to go. So 1 megawatt's the minimum. 2 sea containers would be the minimum. After that, you could put it in an urban area because we do have the highest energy density, very high energy density. So you could put 100 megawatts on 3 acres. If you had 3 acres of space, you could put it down on but often in an urban environment that isn't available. But we would have an edge over most other kind of batteries that way because you do take less space. And of course, if you're not in a town, if you're out in the prairie somewhere in Alberta, you got more room. Then you could add all sorts of storage. But again, 100 megawatts and 3 acres. The other thing about our battery is that heat doesn't matter. So if you're looking at a market, say Australia, we're talking to Australians, we're talking to people in the Middle East, and what they like about our battery is that we don't have to air condition it. Lithium-ion batteries have to be cooled. Our battery runs over 100 degrees C. It doesn't have to be cooled. And the third thing is it's safe. If there was one of the plates broke or there was a spill, there's no fire breaks out. So you could put it in a situation where there are some people living nearby. There won't be any risk of a fire or anything like that, Mark. So it's safe. It's very compact, and temperature doesn't matter to it, hot or cold.
So it could, in theory, be located at a residential substation, for example.
Yeah, I mean, as long as so a residential substation would be, that if I think about the ones in Calgary, I was on the NMAX board for a while. I think about the substations there. They're usually a few acres. So the same kind of substation space, you could put 50, 100 megawatts of power on that same space, Mark, of storage.
What stages are you at with the battery? Are you building a pilot? Is there a pilot operational? What's happening in there?
Well, I believe in tire kickers, and so in my old business, everybody wants to actually see and smell and feel, and they want to see the technology operate. They only believe my blue eyes and hand waving up to a point. So we need to build demonstration projects. So we're building a demonstration project now for the oil application, which again is a net zero, transition technology. But we're also building a demo. We're also building a tire kicker for the battery people because they're the same. Utility companies, people, they want to come and they want to see it operate. They want to measure it. They want to maybe apply their own particular type of scenarios to it, and we can run in any kind of mode. But we're building a pilot, a demonstration project right now, just outside of Edmonton, right beside the oil application, Mark. So it'll be a tire kicker for the battery. It'll be up and running this summer.
Emissions Reduction Alberta takes action on climate change and supports economic growth. Our funding helps existing and new industries in Alberta reduce GHG emissions while lowering costs, attracting investment, and creating jobs. That's why we've invested more than $815 million into 230 projects valued at $6.5 billion. To learn more about Emissions Reduction Alberta, visit eralberta.ca.
And so I'd love to go back to the field upgrading technology for a second, because as you know, we're partnered with Enlighten Innovations on that, and we're really excited to see where that goes. What's the current stage of that demonstration project?
Well, I just want to take a moment to thank ERA, thank the Alberta government, because the Alberta government were the first ones to support us 10 years ago, and we have been on this long journey, been there all along. And I tell you, when you're in this business, it's tough going. You got it for every minute I spend working on technology, I have to spend another minute rounding up money, and my own money too, by the way. So really thankful to the Alberta government for being there for us. There's more than just one valley of death, by the way. You go through a lot of them in the technology development business. Again, it's not for sissies. So I really do thank the Alberta government and ERA for supporting us through this. On the oily side, we are building a demonstration project. It's a great tire kicker. It's 100 barrels a day. It has to be 100 for anybody to take it serious. So it's 10 times bigger than the plant we had before. So on the same site, we're building a 100 barrel a day demonstration project. And again, what we'll be able to show is that we can upgrade Alberta's heavy oil, not just bitumen at the bottom of the barrel, upgrade that to clean marine fuel oil and without emissions. If you use renewable power, we wouldn't have any emissions. So that's the technology we've developed, and it's uniquely good at cleaning up super heavy oils. Now, there's a little extra on that one too. So one market that we're looking at, of course, is marine fuel oil, because we can take the bottom of the barrel in Alberta, take that oil, take out the sulfur, and sell that fuel oil to the shipping industry for diesel prices. So big margin, especially at $100 a barrel. But another application that we're looking very hard at, Mark, is because they're so uniquely good at getting sulfur out of heavy oil. Carbon fiber is becoming a thing now. It's what they use for hockey sticks, tennis rackets, bicycle frames. It's lighter than steel, and it's stronger than steel, and it's the material of the 21st century. Guess what? The precursor, the starting point of that is super heavy oil without sulfur in it, and so we're uniquely good at getting sulfur out of super heavy oil. So we are good at making the precursor for making carbon fiber. So that's an application, Mark, where we don't make a fuel for burning. We make a product where you can make carbon fiber. You can make car bodies, that's right, to replace steel. That's a huge coming market. So that's another application for our technology, Mark.
So when will the demonstration project for the fuel oil and the carbon fiber be operational?
It'll be operational this summer as well, Mark. When we're wrapping up construction in the end of June, we'll be doing commissioning through the summer, and should have first oil in September.
Now, you talked about this a little bit, but I'd love to get your thoughts in your 10-year journey from where you started to where you're at now. What were some of the most notable obstacles and challenges you had to overcome to get to a point where you're poised for commercialization?
Well, it's two steps ahead and one step back. I mean, first of all, it's the technical challenges. Of course, engineers, we love those. You step back and you what the hell happened, and you get some great brains around you, and you crack the nut. You find a way forward again. So those are fun moments, by the way. It's not fun when you take the step back, but it's fun when you move ahead again. So a lot of technical challenges, and particularly with this electrolysis/battery system, it took a lot of doing to get that working properly. And so that's one thing. The second thing is and the third thing is money and money. So the first one is making the technology work. And work reliably and safely and economically. But when you're in this game, it's just getting the money, and having, again, I got to say it, having the Alberta government there for us at the right time has always been a big deal.
Well, summer's coming up pretty quickly. You'll have a big demonstration project up and running. You'll have a tire kicker for this new big ugly battery system up and running. What then? What happens next for Enlighten?
So, that's exactly the right question to ask, because we're not in it to just kind of be a science project. We really want to roll these technologies out and put them to good use. So the oily tire kicker, we have a lineup of refiners, oil companies that are interested in the technology for their refineries, for their applications. They're interested in licensing the technology. Okay, we're also looking at building our own project. So we call this the Clean Seas Demonstration Project. We'd like to build a bigger one. Let's say 10,000 barrels a day in Alberta. Why Alberta? Well, that's where we come from, and there's a lot of feedstock in Alberta. This, the bottom of the barrel stuff. We're bottom feeders. A lot of that in Alberta, and because it's in Alberta, Mark, it's pretty cheap, and we take it, we run it through our machine, and we make fuel oil, and we would take that to the West Coast. So that makes sense at $50 a barrel oil. It makes wonderful sense at $100 a barrel. So there's that, and we also buy, by the way, we get with the demonstration project, we'll use that as the tire kicker for potential licensors of our technology. We'll use that to be the jumping off spot for our 10,000 barrel a day project. So as you scale up, you can't go from lab to 10,000 barrels a day. So 100 barrels a day is a good lily pad for us to jump from. We also want to demonstrate the technology for carbon fiber. So there are people in the carbon fiber business. We think we make a great precursor for carbon fiber. We think we can do that at much lower cost than the alternatives. So we want to use the demo for that. And then of course there's the battery. So what do we do with the battery? Again, there's utility companies, there's people with windmill farms, solar farms, global. This is a global thing. They all, guess what? And investors too. They all want to come and see this battery work at scale. And we'll have 6 commercial stacks in it, exact stacks we'd have in a large application. So they want to come and see it operate. They want to see the power go in and the power come out. They want to see that round trip efficiency you talked about, Mark. So, and where that goes then is that we want to build bigger projects. We want to build 1 megawatt projects. Okay, here in Alberta, also in other places in Australia and other places where there's a lot of interest in this technology. But in order to do that competitively, we've got to make. Remember, I talked about this ceramic plate, this NASACON plate, right at the top of this call. We want to be able to make those cheaply, and so we need to build a gigafactory, and a gigafactory will make these plates, make millions of plates. We need to do that. We need to scale up manufacturing to get the cost down. So that'll be the next step after the demos, Mark.
As you know, I have the pleasure of working with an organization called Emissions Reduction Alberta, and our mandate revolves very tightly around greenhouse gas emissions reductions. And so you're working on some really exciting opportunities, whether it's a Clean Seas demonstration, whether you're producing marine oil, whether you're producing carbon fiber, or whether you're working on a big ugly battery. Can you talk a little bit about how this can help us reduce greenhouse gas emissions and work toward net zero emissions?
Right. So I think we're a transition. Enlighten's a transition company because we're actually, our history is transition. We started with oily and ending up with oily and battery and carbon fiber and so forth. I think the transition is going to be a journey. By the way, I read Vaclav Smil a lot. He's a Vaclav Smil. He's a writer. Writes up on energy. I think he wrote a book called Energy and Civilization, and he's Bill Gates' favorite author. He's at the University of Manitoba. And he says that any energy transition, that went from sail to steamships, and they went from steam, coal to oil and oil to gas. It takes several generations, maybe 50 years. So it'll take a while to get through all of that. So we'll still need oil for a while, but we need to process oil cleanly. So that's the oil application. That's the clean Cs. The battery application is here and now. I mean, if you're going to start taking power stations off the grid, you're going to start taking coal and gas-fired power stations off the grid. You're going to have to replace them with big ugly batteries, or nobody wants to freeze in the dark, right? So as that happens, if you bring off coal-fired power stations, that'll cut emissions, and we have a battery for that. That's our big ugly battery goes in there. So, and every time you see a coal-fired power station coming off the grid being replaced by a big ugly battery, there's a huge drop in greenhouse gas emissions right there. And of course, carbon fiber. Carbon fiber is the material of the 21st century. I mean, if you're going to make, if you make lighter cars, lighter airplanes, you're just going to use less energy. So if you can replace some of that steel with carbon fiber, you're going to reduce energy as well. So all of the things we do, whether we're making marine fuel oil in a net zero way, a big ugly battery to replace fossil fuel power stations, or making carbon fiber to replace steel and lighten up cars, all of that plays to reducing greenhouse gas emissions.
So in this 10-year journey you've had with Enlighten Innovations and this sort of variety of opportunities that you find yourself able to have an impact in and to create products for, what are you most hopeful and excited about for the climate change that we all face?
Well, I started with oil and I understand oil a lot, but I think the battery is the exciting one, frankly. I mean, and it proves it through with investors. I mean, investors are at least 10 times more interested. I know I deal with investors, half the time, and the other half of the time trying to figure out how to improve our technology. But investors are really interested in batteries, and that's the future. I mean, 50 years from now, there'll be a lot of big ugly batteries. There'll be a lot of things. I mean, not just our battery. There'll be a lot of different technologies. But I think that being part of a discovery and a commercialization in Alberta of a technology that at scale, and not just playing around with laptops and that. I mean, at scale can replace coal-fired, gas-fired power stations. That's a really, I really feel proud of that. And the fact that it's cheap, it's easy. They're easy to make. I can scratch up the materials right in Alberta to make one of our big ugly batteries, no problem, and they're safe. So it's an Alberta engineered machine that has global legs.
Is there enough sodium and sulfur to be able to capture that market?
Yeah, again, they're the 10 most common elements, in the top 10 most common elements on Earth. Like, seawater is sodium chloride, so you can recover sodium from sodium chloride. So lots of sodium chloride around. Sulfur, you only have to fly up to Fort McMurray. You'll see lots of sulfur. Alberta's just got lots of sulfur. And the plates themselves are made of sand. So, so we have all the ingredients to be able to make all the batteries that we need. We just have to step up our manufacturing. Along the way, this is a tough road to kind of tough it out for 10 years. You're not making any revenue. You're getting a lot of setbacks. So it's not a job for sissies, and it's not a job for people that don't have access to finance. So I got to really thank my shareholders, my partner, and my shareholders, and also again the Alberta government, ERA. You guys have been with us there the whole journey, and all through all the twists and turns, all the setbacks, all the COVIDs and the scaled up challenges and so on, and now the battery too. And I think that again, I just want to be thankful for all the help we've had getting us this far.
Well, it's been great talking to you today. It's been fantastic getting to know you over the years, and I really look forward to seeing both the demonstration projects up and running, perhaps as early as this summer, as well as what happens next. Thank you so much for taking the time today.
Great. Thank you, Mark.